Hi all, this is Saikat. Today I'll be giving a brief background on the ICC3 that you have due on the Monday. This ICC is targeting on MOSFETs and HBGs and their application as switches and how to use a MOSFET to drive a motor or actuator. Um, the main primary resources regarding this assignment is given in the manual. You can go through all of them if you want. I would recommend to go over this website on electronics tutorial. This will make you learn how to use a MOSFET as a switch, and also regarding this assignment and on how to drive a motor using a switch. The parts that are needed for this assignment are given here. You would need the 5-volt power supply that you had built for the ICC1. You can use a benchmark power supply as well, but we want you to use this 5-volt power supply that you had made in ICC1. Also, the MOSFET that was given in the last class, you'll be using that. You'll be using the motor driver, fan 8110N. You'll be using a gear motor that will be provided in the class and will be kept on the benches. The resistor, push button switches, the diode, the bench power supply, all are there with you in the kit. Regarding the motor preparation, I would like to say you need to solder 2 wires with the motor to terminals of the motors. We have already kept few motors. Those are like already soldered on the terminal. The wires are soldered on the terminals. Probably you don't need to do this stuff, but if you need to, you can do that. Also, regarding the motor driver has 12 pins on it. You need to bend the ground pins. Those are on the both sides of the two sides of the motor, and using the pilers, and you can then put it in on your breadboard. Remember that to solder 2 wires, jumper wires, with the motor's ground terminals and ground them on your board. Regarding the first part of the circuit, revolves around driving a motor with one particular MOSFET, and the MOSFET power supply is 5-volt that you can see here. You can use a SPDT switch that you have in your kit, and you can drive your MOSFET as a switch turn on and off by turning on and by pushing the push button switch. Keep in mind that the motor here works like an inductor, that there's a coil that energizes in the motor, and that actually helps revolve in the motor shaft. There is a diode that is connected in parallel with a particular fashion. You need to identify what is the purpose of it. I can just say that the motor can, when the current is flowing, the motor gets energized, the coil gets energized, and when de-energizing the coil, it needs a path to de-energize. For that reason, you need the diode. You can go through your book that is recommended to find out what is the use of this flywheel or flyback type diode. You need to also identify what is the maximum VDD level that you can provide during this experiment. You can take a note of this from the data sheet of the MOSFET as well as the motor. Also, I would like to give a live demonstration of this that I had already prepared earlier, and you can probably see this. So this circuit is for 5-volt that is coming from the ICC1 that we had built. So you can see it is regulated at 5 volts. When I put it the 5-volt, we use the 5-volt as the supply for the MOSFET gate and connected in series with the switch. You can see I'm giving a VDD of 10 volts across the motor terminal and the MOSFET source. You can see if I push the switch, the motor rotates in a direction. Sorry. Yeah. Now going to the second part of the circuit, second part of the assignment, we need to build a H-bridge motor controller. The motor controller is given to you. You need to identify the maximum PVCC level of the motor driver. You can go through the data sheet of the motor driver, identify what is the maximum VDD or VCC that you can provide to the driver, and This is the internal block diagram of the motor driver. We will be using one H bridge, not the both of them. There are two H bridges inside the motor driver. We'll be using only one. Also, you can go through the whole data sheet. This table is very important for you. So there are two switches, two push button switches. How you can operate them? What are the logic levels of them? There can be 0 or 1. What will happen if both are 0, both are high, or one is high and one is low? What will happen to the motor? You can identify this from this table, and also you need to demonstrate the working of the circuit according to this table. I can show you this video here. That I had built earlier. You can see if I'm pushing one switch, it is going into one direction. Maybe let's take it a reverse direction. And if I am pressing the other switch, it is going into the forward direction. That is one thing you need to demonstrate during the experiment. And that's all. I would want to give you one tip on this switch, how to use the switch. So you can see you have this kind of spaced switch. You can see the top row is actually sorted inside the switch, and the bottom row is also sorted inside the switch. So how the switches operate is that you need to press the switch to connect the top row with the bottom row. Vice versa.